Welcome to this video on solving simultaneous equations where we have three unknowns and three equations. So in this first example, we're to find what x, y, and z are. And to do this, we start by numbering the three equations that we're given. Okay. Now, sometimes I would rearrange them first, but these are all given in the form something x plus something y plus something z equals a number, and it's best if we start with them in that form. Okay, now I'm going to look through the three equations and see if there's anything I can do to one of them to make it match one of the others so that one of the terms has the same coefficient. So for example, I could double equation 3, okay, and that would give a 2x term, and it would enable me to eliminate x. And this is how it works. So I'm going to start by doing equation 3 times 2. So I write it like this: 2 times equation number 3. Okay, putting that in a circle. And just simply doubling that equation. So I'm going to have 2x minus 2y minus 6z equals negative 40. Okay, and as soon as I've made a new equation, I'm just going to number it with the next available number. So that's going to become equation 4. Okay, and now I'm going to say, well, both equation 4 and equation 2 contain 2x. So if I subtract one equation from the other, I will eliminate the x term. So I'm going to do it this way round. I'm going to take away from equation 2, which has a 7y, I'm going to take away equation 4. Okay, and that'll keep all the coefficients positive, or at least that one anyway. So here we go. So it's equation 2 take away equation 4. So that's on the next line here. Okay, it's equation 2 minus equation 4. Okay, and what would that be? Well, it would be 2x minus 2x, which is 0. That's why we did it. It would be 7y minus negative 2y, which is 9y. Okay, be careful about the subtracting a negative number. And we've also got 2z minus negative 6z, which is actually 8z. So it's 9y plus 8z. Okay, and if we subtract, if we do 27, take away negative 40, it actually gives us 67. Okay, so I now call that one equation 5. Okay, so now we need another equation just linking x, y and z together without x. Now what I could do is I could double equation 2 so it contains a 4x, and then I could eliminate x from equation 1 as well. So what I'm going to do is take equation 2 and multiply it by 2. So 2 times equation 2, that's going to give me 4x plus 14y. Okay, and I've also got 4z, and that's going to equal 54. Okay, so I'll just change that to make it look like a plus sign. Okay, so that means that I can now call this one equation 6. And I need to match together equation 6 and equation 1. Now if I subtract them, I will get rid of the 4x term because they both contain a plus 4x at the front, you see. So if I do equation 1 take away equation 6, that would give me a negative 11y. That would be okay, but it's better to do it the other way around. I'm going to do a 6 take away 1. Okay, just so that I start the equation with a positive term. Okay, so 4x take away 4x is 0, 14y take away 3y is 11y. Okay, then I've got 4z take away negative z, which is plus 5z. Okay, and I've also got 54 take away negative 4, which is 58. Okay, so I've now made another equation containing just y and z, which I'm going to call equation 7. Okay, so I've now got two equations, 5 and 7, that contain only y and z. These two here, I'll just show that I'm linking those together like that. Okay, now this is like having two equations with two unknowns. So what do we normally do in that situation? Well, we look at the coefficients of y and z, and we try and make any pair of them the same. It's a bit like finding a lowest common multiple of one of the terms. So I could change both of these y terms into 99, or maybe easier, I could change the z terms into 40, which is the the lowest common multiple of 8 and 5. So I'm going to do that. So I'm going to take equation 5 and multiply it by 5. Okay, so we have 5 times equation 5. Okay, which is going to give me 5 times this, which is 45y, plus 40z, and it's also going to give me 5 times 67, which is 335. Okay, and I'm going to call that one equation 8. And then to find this equation 7, to get that z term also to be 40, I've got to multiply that whole equation by 8. So I'm going to need to do 8 times equation 7. Okay, and that's going to give me 88y. Okay, it's also going to give me the 40z, which I knew about. That's why I did it. And it's also going to give me 8 times 58, which is going to be 464. Okay, and that now becomes equation 9. So what I now need to do with equations 8 and 9 is subtract them to get rid of the 40z term. Okay, so if I go over here, I'm going to do equation 9 minus equation 8, and that's going to give me, well, it's going to give me 88 minus 45, that's going to be 43y equals, and it's going to give me 464 minus 335, which is 129. And you may be able to spot there straight away that that means that y is exactly 3. Now that's always reassuring because it's an integer value, and usually these equations lead to integer solutions, but there may be decimal solutions or fractions as well, so you can't always assume it's going to be an integer. Okay, but it is in this case. So once we know one of the three solutions, the rest of it snowballs very quickly and we get the other two. So all I need to do now is take that value of y and sub it into any of these equations which contain two variables. So I could sub that into equation 7, for example, which I wrote here, which contains only y and z, and that would tell me what z is. So I'm going to sub, let me do it here, so I've got to keep my space. So I'm going to substitute, and I always say what I'm going to do here, substitute y equals 3 into equation 7. Okay, and what's that going to give me? It's going to give me 11 times 3 plus 5z equals 58. Okay, so if I work on that, that's 33 plus 5z equals 58. Take away 33 from both sides. I get 5z equals 25. Okay, so 5z equals 25, and therefore z equals 5. Okay, so I can very quickly find a second solution, which is there. And having got 2 letters now, all I need to do is take both of those and substitute them into one of the earlier equations. In fact, one of the originals may be this one here. So I can sub both of those into equation 3 to find the third unknown, which is x. Okay, so I'm going to sub y equals 3 and z equals 5 into equation 3, and that's going to give me, well, let's just write that down there. So x minus 3 minus 3 lots of 5, and that's going to equal 20. Okay, so I'm putting all of that information into this equation here. All right, and then just rearrange that. Well, that's minus 15, that's minus 3, so it's minus 18. Add 18 to both sides. Oh, that's minus 20 there, of course. So I've got minus 20 plus 18. That's going to give me minus 2. So x equals minus 2. And that is the solution set for that equation, those simultaneous equations. So x equals minus 2, y equals 3, and z equals 5. Okay, whichever way you do this, there's going to be a lot of work to do. Okay, you don't get these answers easily, especially the first one. But once you have found the first solution, then the rest of it happens quite quickly, as you just saw. Okay, so let's move on to the second one. Now we've got decimals here in the answers in the right hand side, plus they're arranged in different orders. So the variables x, y, and z are not sorted in any particular way, and they're different in each equation. So my recommendation here is to always start by putting them in the same order. Okay, so I'm going to do that and then call my equations 1, 2, and 3. So let's write them up here. So the first one I'm going to rearrange to give me minus x. Okay, let me write them here. So minus x plus y plus 2z. Okay, and all of that equals 2.1. Okay, so that's the first one, just rearranged. And I'm going to call that one equation 1. Okay, the second one I'm going to write as 3x minus y minus 2z. So I'm just changing the order of the variables there. Okay, and that equals negative 2.5, because what I'm doing is I'm subtracting the 2.5 from both sides. Okay, and that's going to become equation 2. And finally, I've got to make equation 3, which just means reordering everything. So the x term is at the front, 5x plus 10y and 8z. Okay, and that equals 4.5 for equation 3. Okay, so that was a fairly straightforward process just to rearrange the order of the variables. Okay, and that's equation 3. Now, just by inspecting these very carefully, there's a bit of luck here really, because when you now look at these first two equations, because that contains a plus y and a plus 2z, and this contains a minus y and a minus 2z, if I were to add together these two equations as they are now, without doing anything more to them, I would immediately eliminate both y and z, which would enable me to find x very quickly. So actually, this is quite simple to quickly establish what one of the variables is. So I'm just going to simply say here that I'm going to take equation 1 and equation 2 and add them together. Okay, so 1 plus 2. Now, of course, you wouldn't normally get something like that. That's well, you might do, but you can't assume that. So this is making it easier to start with. So minus x plus 3x is 2x. Add y and minus y together, we get 0. 2z and minus 2z is 0. So 2x must be 2.1 minus 2.5, which is negative 0.4, which means that x must be 0.2, negative 0.2. Okay, as simple as that. So that's a very quick solution to get us started with. Now, having established that, I need to substitute it into one of the other equations. Now, the thing is, I haven't got an equation at the moment that only contains y or z. I've still got two variables to find. So what I'm going to do is I'm just going to take that value of x and substitute it into both 1 and 3. So I'm not going to use the two equations I've just used, but I'm going to use one of them and a different one. Okay, so let's see how that would work. So let's substitute. So we're saying what we're doing here. So I'm substituting x equals negative 0.2 into 1 and 3. So I'm making two substitutions. So let's do that and see what we come up with. So substituting it into equation 1, I've got, let's have a look, we've got 0.2 because it's negative x. Okay, so it's 0.2 plus y plus 2z equals 2.1. Okay, 2.1. That should say there. Okay, so that's substituting it into the first one. And then if I take away 0.2 from both sides, that will give me, let's tidy it up a bit, that will give me y plus 2z equals 0.9. So it's an equation that only contains two variables now. Y plus 2z equals 1.9. Okay, and I'm going to call that one equation 4. Okay, now I'm going to take the other equation, which is equation 3, and substitute negative 0.2 into that. Okay, so I'm going to have 5x, so 5 times negative 0.2, okay, plus 10 lots of y plus 8 lots of z equals 4.5. Now, if I just work that out, 5 times negative 0.2 is negative 1. So that will give me 10y plus 8z, 10y plus 8z equals 5.5, because I'll take the negative 1, add it to both sides, add 1 to both sides, and that will change that to 5.5. And that will become equation 5. So now you see I have two equations containing two unknowns, y and z. These two here, which I've called 4 and 5. So what I could do now is notice that equation 5 has a z coefficient of 8, whereas this has a z coefficient of 2. So if I made equation 4 times bigger, then it would also contain 8z, and I could eliminate z. So what I'm going to do now is I'll just move up here. So I'm going to take 4 times equation 4, okay, which will give me, that will be 4 times equation 4 would give me 4y plus 8z, okay, 4y plus 8z, and that would give me 9 times 1.9, which is 7.6. And I'm going to call that one equation 6. Okay, so from equation 6, if I now subtract, if I do equation 5, take away equation 6, that will eliminate the z term and give me the following. Okay, so I'm just going to do equation 5, take away equation 6. Okay, and that's going to give me 10y, take away 4y is 6y. It's going to give me 8z minus 8z is 0, and 5.5 minus 7.6 is negative 2.1. Okay, well, it does work out, because if you divide both sides by 6, you get that y equals negative 2.1 over 6, which is actually negative 0.35. Okay, so we now have a value for y. So the only unknown that we still have is z. So what we could do is just substitute y for that number into one of these equations we've just done, maybe equation 4. So if I substitute y equals negative 0.35 into equation 4, that would give me that y plus 2z, which is now I need its y is what I've already got, so let me put that in. So it'll be minus 0.35 plus 2z equals 1.9. Okay, if I add 0.35 to both sides, that gives me that 2z equals 2.25. Okay, 2z equals 2.25, and therefore that z equals half of that, which is, that's 2 1/4, so it's 1 1/8, or 1.125. Okay, now you could give those solutions as fractions. So that one would be 9/8. This one would be 35 over 100, so it's 7/20 and so on. But that's fine to leave them like that. The question contained decimals, so it seemed appropriate to keep working with decimals. So there we have it, 3 solutions. Now if you check those back, you'll find they work. So if you replace x, y and z in any of those 3 equations with those 3 numbers, they will all indeed work out to be true, as of course is the case with these here. Okay, so whichever way you do these equations, there's many different routes you could take. There's going to be a certain amount of hard work to do to get there. Okay, sometimes you just strike it lucky where you notice something that will immediately give you one of the answers. Well, obviously take advantage of that if you see it. Otherwise, you've just got to work through and reduce it from 3 equations with 3 unknowns down to 2 equations with 2 unknowns, and then finally eliminate one of those to get one solution. And once you've got that, everything happens very quickly. Okay, so I hope that was helpful. Take care.